Okay, good afternoon, everybody. It's 3 o'clock. I see there are people still joining and people still connecting to audio. I hope that the connections sort themselves out relatively soon, because we'll be getting started with session 3AJ, which is understanding TS7700 object store for zOS data. I think this is a fascinating interplay between DS8000, TS7700, and DFSMS, and it's notable that we have three speakers, one from each area, and I'm sure that they'll describe to us just how the interrelationship works. I do find this topic a very interesting development. So, having given you the brief advert, I'd like to hand over to Eddie Lynn to start. Eddie, the floor's yours, or at least it will be when I remember to make you co-host, which you are.
Great. Thank you, Nigel. All right, well, greetings, everyone. Greetings from across the pond. Over here, everyone is probably getting their afternoon drinks, but we over here in Tucson, Arizona, and in Dayton, Ohio are drinking our coffee. So I wanted to say hello, everyone. My name is Eddie Lynn. I work in DS8000 architecture based out of Tucson, Arizona. I am joined with two of my cohorts in the storage space. I have Lori Goodall. She is also based in Tucson, Arizona. She is an architect in the TS7700 virtual tape product. And I'm also joined with Robert Gensler. He is the DSS product owner, as well as an architect in DFSMS. So the three of us will be going over understanding using a TS7700 as an object store for zOS data. The session number is 3AJ. And we're going to go ahead and get started. So I wanted to start by framing the discussion as to, why are we doing this, and why all of these complementary products are working hand in hand into providing you a solution for the backup and archive space. The backup and archive space in the mainframe has been around for a very long time. A lot of the products have been around over 40 years. So if you're a DFHSM user, HSM had just celebrated its 40th birthday a year or two ago. So it's been around for quite a while. And what we want to try to do here is IBM is trying to make things more efficient. We're trying to make things more consistent and complementary. So I kind of want to get those three words, an E, a C, and a C, and ECC doesn't relate to memory, but it's efficiency, consistency, and complementary. So as we're going through these discussion points, we want to see how we can make backup and archive for the mainframe more efficient, how we can keep the way that you do your backup and archive today the same or very similar to the way you use your software today, so consistent. And the third thing we want to talk about is we want to talk about how we can make it complementary. We are trying to combine technologies in order to be able to do things at the same time. So for instance, in the TS7700, it's a virtual tape product. It does tape workloads from various applications, HSM, DSS, all can land on the 7700. What we want to do here is we want to complement that with this object store technology in order for you to take advantage of the efficiency without really changing the way that you are ingesting tape data at the same time. So our goal here is we want the Z, or the mainframe, to become just the information lifecycle management software. Makes policy decisions, you make the decisions on what data you want to send, and it gets out of the movement of data through the mainframe. We want to move that to the DS8000, your primary storage device. We want to make it the primary data movement engine. Last but not least, we want the 7700 to be the target of that data, whether it's tape or whether it's now object. So the combination of these three products together provides the solution that we're going to be talking about. And that solution is called transparent cloud tiering. So I just want everyone to just kind of focus in on the left-hand side, the picture, and this is a recall. So this is what we're doing here is a recall of data from tape. It's how it works today. All of the lines are, or arrows are a description of how the data flows in order for a recall to end up back in the user's hands. So to get something off a tape, we have to read it off of the tape. We have to go, the data has to flow through the mainframe. It has to get blocked by 16K blocks and it has to be manipulated and then stored back on disk. And then after it's on disk, then we have to read it back into the mainframe again. So those three different patterns, all of that data flowing through the mainframe. What we want to transform that, and this is the efficiency statement, the E in the three words that we're talking about. So we want to switch that from being three different paths to get to the data from the target object storage to go directly to the primary disk. So what we want to do here is by eliminating all of the arrows on the left, we're basically taking the data from the object storage and putting it directly on our disk. The disk is where the data already is being stored. So it makes more sense that the data that is being stored can maneuver the data both back and forth from the object storage. So this is the efficiency play. This is what transparent cloud tiering does. And this is the reason why we created this solution. For those of you who are familiar with transparent cloud tiering, it's been around for a couple of years now. And for the most part, on the right-hand side, we've been talking about going to object storage. So you'll see there's other sessions that talk about maneuvering data to cloud object storage or to the cloud. We still support that today. S3 compatible object storage is still supported today. We can maneuver HSM, DSS, dumps, and full volume dumps, and all those things out to object storage today. But what we want to try to do now is, and it's highlighted in the lower right-hand corner, is we want to give the opportunity, instead of a traditional object storage, is now you can use transparent cloud tiering with a TS7700 as an object store. And the key thing here is, and Lori will be going through this in some detail, is that we have the ability now to partition part of your virtual tape to take these objects and then be able to continue tape workloads to the other partitions as you do today. So that's a very exciting feature that we're going to be talking about. We'll also be talking about some new use cases. Robert will be talking about some of the new use cases that we're expanding the ecosystem of transparent cloud tiering. The last thing I wanted to say about this slide is that the lower left-hand corner is our value statement, right? So we were talking about efficiency and we were talking about not maneuvering the data and not reblocking the data through the mainframe. Well, what does that buy you? Well, the lower left-hand corner talks about a 7 gig data set that we migrated out to ML2 tape, which is the way that it's done today, uses 7.5 CPU seconds in order to do that operation. The TCT bar on the right-hand side in blue is the amount of CPU seconds that it takes using transparent cloud tiering. So it's an extremely noticeable difference going from 7.5 CPU seconds down to 0.05, over 90% savings in CPU or MIPS. So that's a key. This is how we're getting the efficiency back to the user and back to you as the backup and archive administrator in your shop. For those of you who are HSM users, we do have a tool out currently today, links at the bottom. And what we can use is we can take your existing production SMF data without modifying anything, be able to pull that SMF data, run it through this tool and give you an estimate as to what percentage of CPU savings you can gain by moving to using transparent cloud tiering. The example over here, you see it's by day. One day would be 46%, 78%, 65%, all based on the amount of data that's being migrated and the size of the data that's being migrated. So I encourage anyone that's interested, that's an HSM user, to try out the tool. It's free. You can go out there and be able to run it today. So a key thing that is different about the way that we do our manipulation and maneuvering and transferring of data is that we're not tape. So that's one key thing, is that we store all of our data sets or dumps or backup data. We store all of those as individual objects. And that is different in that on the right-hand side, you'll see that traditionally you have a Valseer, you have a tape, it's a size, 2 gig tape, and you go through all of those tapes, you recycle those tapes, you go through all that processing. That's the way that it currently works today. But on the upper right-hand side is how it's going to be with transparent cloud tiering. So the upper right-hand side is an example of a data set. And you'll see that there's some values that are in blue and there's some values that are in gray. So we split apart the metadata with the customer data. So the blue is metadata. So we are able to store zOS metadata, HSM metadata, self-describing DSS metadata, VTOX, all this kind of information in this metadata as separate objects from the customer data. And why is that important? Well, I can do things in the future to be able to index those metadata, to be able to search through the metadata without having to pull back any of the customer data. Your customer data is going to be the largest piece of this whole pie. So being able to transfer a 4K VTOC or a very small piece of information will be able to allow us to determine whether or not we want to recall or restore the data that's customer data, which could be gigabytes, hundreds of gigabytes in size. So that's a key difference there. The second thing is if you're using HSM, we have a whole nother tier of the cloud. So we used to have ML1 and we had ML2. Now we have migration level cloud. All the Valseers are modified when you migrate something out to the cloud. It will be Migrat C instead of Migrat 1 or Migrat 2. So it's all integrated with HSM. The other key thing here is that when we recall the data and we migrate the data, we don't have to go through ML1, ML2 to get to MLC. We go directly from ML0 to MLC. Those are key differences in the way that we do things versus the way that we've traditionally done things before. So I want to keep that as an educational point that when we start talking about objects versus tapes, there's a key differentiation between the two. Here's our use case summary. We're going to be talking about one of the new use cases, but we've been consistently growing what TCT is able to do. For the longest time, we've been in the targeted HSM automatic migration of data sets. We've been doing that for, ever since we started. But ever since then, we've been growing and adding more and more use cases and more ways that we can take advantage of this technology. We've been adding the ability to do DB2 image copies. So doing a DB2 point in time copy and then using DSS and then using migrate storage group using HSM to move that point in time copy to the cloud or to the TS7700 in this case. DSS has had the ability to do data set backup for using TCT. That still exists today. What's new is we have the two capabilities. Now we support DSS dump full or DSS full volume dump support. This is native DSS using the dump command. Robert will go through those use cases and some JCL and some more detail in a few minutes. But we now support the ability to do that, and also the ability to do a flash copy and then using that target flash copy to dump that over to the cloud. Both of those things are native DSS at this point, but we do have a statement of direction for next year that HSM will also support full volume dump support. So you can use either HSM or DSS in your environment to be able to move those things to these object stores. I have some new things to talk about that are new very recently, and it all applies to using this TS7700 as an object store. So one of the things is now we support compression, and this is not compression in tape. This is compression in the DS8000. So what we're doing here is if you have a DS8900 and you have a certain level of 9.1 microcode, which was just recently released and GA'd, without any additional feature codes, and your object store is configured to be a TS7700, we are now able to compress the metadata, or I'm sorry, we're able to compress the data. We only compress the customer data. We don't compress the metadata. The metadata is very small, and there's really no advantage to compressing a very small metadata object. What we do is we compress the customer object, which is the extents object, the largest piece of the data. The other key note that we're doing here is that we're compressing the data inside the DS8000. So before the data ends up on the Ethernet to the cloud or to the TS7700, we are compressing it within the DS8000. So that saves you bandwidth because we're transferring less data because we're already compressing it. And we are also saving space as it lands on the target object store. The other key thing is, I was talking about the efficiency statement. It would be kind of pointless if we had an efficiency statement that we maneuvered CPU off the mainframe and then we just added it to the DS8000 and impacted your active IO or your databases and stuff like that. This compression engine is hardware accelerated, so it does not use any additional CPU and does not degrade the performance of the DS8900. And that's part of the built-in compression accelerator that's inside the Power9 KEC that we have in our DS8900. Last but not least, DFSMS has the capability of knowing that a data set or a dump is already compressed. So if you're using ZDC or Z15 compression, DFSMS already knows that it's compressed. So DFSMS is in control of telling the DS8000 whether or not we need to compress the data. If the data is already compressed, or if the data is already encrypted, if you're using dataset level encryption, DFSMS can tell us not to do the compression. You obviously don't want to do compression on an encrypted object because that could, in fact, grow the size of the object. So DFSMS has this ability to be able to tell us whether or not we need to compress. So that's new, brand new. It just came out a little over a month ago. The other thing that's related that's new to the 7700 is the idea that we can encrypt objects as they flow across the Ethernet. This is, again, a DS8900 only solution, requires that 9.1 microcode. It does require a feature code on the TS7700, which is called secure data transfer. If you have a grid environment and you already have TS7700, you can already be able to use secure data transfer to encrypt all of the data around your grid. This takes that and sticks it into the DS8000 so that we can participate in that same encryption. It's AES 256-bit TLS 1.2 encryption over TCP/IP, and again, hardware accelerated. So we're not impacting the DS8000's performance by doing the encryption. Last but not least, again, DFSMS, they're really smart up there. They already know that data has already been encrypted or it has already, and it's either compressed or encrypted. So they can also tell us whether or not we need to do the encryption. So with that, I wanted to kind of take the next step and move forward and talk about in more detail the TS7700 as an object store, and kind of give you some more details on how it works and how it's laid out, taking advantage of all the things that I talked about before and where we're trying to go with this solution. So I'm going to go ahead and hand it over to Lori, and she's going to go ahead and give everyone some more details on that solution. Lori?
Hello, thanks, Eddie. Hopefully you can hear me okay. Go ahead and go to the next slide. All right, so TS7700 is an object store. What does that mean? So 7700 has been known for being a virtual tape server since its origination. In fact, it is a 5th generation VTS for the IBM products. But what does that really entail? So if you think about virtual tape, we are a 3490 tape protocol emulator. So we speak in 3490 tape language. We are a virtual storage server in the background. So in the front end, we look like tape, but we're really not. We're just pretending to be tape. So what is that? How does that flow into object storage? If you think about object storage, that's really basically what object storage is. It's a virtual concept. So we kind of naturally flow into that ability to store objects. To us, those logical volume data is really just objects sitting in our cache system. And we're really just doing the same thing, just talking a little bit different language on it. So TS7700 being a target for the object store, great capacity, utilization of your storage that you already have today. But the big thing here is that you can intermix that FICON tape workload, that virtual tape, with this object workload in the same 7700, and we just kind of naturally can store that data in our system. It's something that we already do with tape, just not very visible to our customers. So this is supported on TS7760s and TS7770s. And the data itself flows through Ethernet. So we utilize the same grid network links that already exist in your 7700. And in fact, we use the Ethernet adapters that already exist in your DS8000. So there's no new hardware on that aspect. It already exists on your system. It's just a matter of cabling that up. We are also storing this data utilizing our logical cache partitioning. I'll talk a little bit more about that, but it's a technology that we've been using for years now to separate kind of your workload for your tape data and your cloud data. And we also support redundancy, so you can target 1 or 2 TS7700s in the same grid from a DS8000. Next slide. All right, so on a TS7700, today we support 1 to 8 clusters in a grid. The object data can target 1 or 2 of those 8 clusters for a single DS8000. In fact, you can have multiple DS8000s even targeting the same 7700. There's no problem there. And each one of these 7700s today could be a disk-only system, or they could be tape or cloud attached. What does that mean? This is tape or a tape library extension of your 7700, where we can move logical volume data into physical tape, or we could have an S3 cloud storage device on the back end of our system too, to move logical volume data out in that sense. In this first release, the object data, however, will be resident only, meaning we don't have the ability to migrate that data to tape or cloud, so that data resides in cache. Once again, I talked a little bit about multiple DS8000s targeting the same 7700, or they could be targeting different clusters in the grid, however you need to configure it. And one thing really nice about this is that you don't need an additional cache, you don't need an additional object storage device, anything. We utilize the same cache storage system that's already in your 7700. So how do we separate this out? So logical cache partitions, like I said, is a concept that we've had out for a number of years. This is how we allow management or different management of your logical volume data to tape or to cloud at the back end of your TS7700. And basically all we're doing is taking one of those cache partitions and marking it as an object type partition. And that's where all your objects will be going. So it kind of virtually separates that data from your logical volume data so that you can statistically tell, how much cache utilization, or how many objects do you have within your system for DS8000 workload versus your tape workload. So this coexists. An object store TS7700 can be on a tape attached, a cloud attached, or a disk only, and we just logically separate that out. Next slide. So one of the main advantages of moving objects, so Eddie talked about the MIPS savings that you get in host. So that's just one of the big items that you save, but another major advantage is your ability to do parallel access to an object. As you know, today, when your data is all stored into one logical volume, if you have to pull a data set out, or let's say you have to pull two data sets out that are in the same logical volume, that is handled serially with tape protocol. With objects, that's gone. Your objects are stored as objects in the 7700, and if you need to go recall a data set, then it's ready to go. It's all separated already. There's no waiting. So it resolves that serial access issue that you have. Next slide. A third and just as important item that this problem resolves is that HSM Reclaim, that recycle that you have to go through. So on physical tape, or on virtual tape even, when you store all that data into one larger volume of data, that data expires separately, differently. Data sets, as they are expiring in the 7700 or any virtual tape server, that data can't be peeled out of that volume of data. So basically the 7700 retains that information until that logical volume has a certain percentage of active data left on it that you've decided, that percentage, whatever percentage that you want. So once it reaches that percentage, let's say you set it to 25% of active data, and then I want to go reclaim that data, then each one of those logical volumes has to be recalled back up into the host, rewritten into another logical volume, and then written back down to the 7700. And anyone that works with virtual tape servers understands how often this is like a daily thing that you have to go through. You can just imagine how much resources and time is spent just doing this reclaim cycle. With the DS8000 TCT, we no longer have that issue because of the data being stored as objects. Once it's deleted, then it's deleted. There's no more waiting to reclaim it and reclaim that space later on. That space is now opened up to do other workloads. So it totally eliminates that for this workload. All right, next slide. Okay, so what do you need to make this all happen? So on the DS8000 side, we have DS8880s and DS8900s that support TCT. You need the Z Synergy license bundle for the code paths. On the DS8880, the minimum code level is 8.5 Service Pack 4.1. For the DS8900, the minimum level is 9.0 Service Pack 1. However, if you want to take advantage of the encryption and compression that Eddie just talked about, it does require the 9.1 level of code. Just a note on Ethernet, I talked about that both the DS8000 and the 7700 come with Ethernet adapters. Totally recommend that you go with the 10 gig because of the amount of additional traffic that you're going to be putting onto your grid links, plus just the larger bandwidth that you'll get. But one note is on the DS8900 and is the technology between the 7700 and 8900 on the 10 gigabit Ethernet are not the same. There's a difference between short reach and long reach. So you cannot direct connect those adapters. You'll need some switches in between to use as a bridge for those protocols. So just a note there. As I already said, VEC, VEDs are supported on the 7700 side. Minimum code level is release 5.0. It does require feature code 5282, which is the DS8000 object store feature. That must be installed on any TS7700 that you're going to have as a target for TCT. And on the zOS side, version 2 release 3 or higher is required. If you are going to use 7700 as a target, you want to make sure you have the correct APARs. There's a list, I didn't list them in here. But the other thing too is that with the new release that just came out this year that supports the DS8000 compression and the new DSS full volume dump that Robert's going to talk to you about next, there's additional APARs for those as well. Next slide. Setup, you know, this sounds like a monster of a thing to set up, but actually it's not so bad. I mean, other than overcoming the network items that you need to do to make sure that your DS8000 and your 7700 can talk to each other, the setup is actually fairly simple. On the 7700 side, again, activate feature code 5282. That's just a management interface panel that you activate that feature with. There's a enablement procedure that you have to do on the 7700. An SSR needs to do it. They have to take the 7700 offline, but the actual enablement is like a 2-minute process. Once that 7700 is back online, or even while it's offline, they need to enter DS8000 serial numbers and IP addresses for those CACs that will be talking to the 7700. So those need to be entered. Again, really short procedure, takes a couple minutes to do. And then once you've enabled the object store, you'll have access to that object cache partition I spoke about, and you'll want to go and resize it. It's sized at 3 terabytes initially, and you'll want to increase it to whatever capacity you want for that workload. On the zOS side, you'll want to create a cloud network connection construct. This is found in the zOS ISMF cloud panel, and you'll want to choose tape object as the provider. That will say that you want to target 7700 so that the zOS knows how to talk to us. The other thing you want to do is go in and create or modify your management class constructs. Specifically, there's several knobs, but specifically you want to modify the level 2 days non-use to 0 if you're going to be targeting a cloud object store. Instead of ML2, it will be an MLC. And then last, on the DS8000 side, you need to enable those Ethernet ports. They don't come enabled by default, so they just need to be enabled. And then you're going to be entering the TS7700 grid IPs, just like you did on the 7700 and adding the DS8000 IPs, but you'll be adding those grid IPs to this DS8000 and specifying the network connection name. That is the cloud network connection construct that you just set up in zOS. You need to specify that connection name so it knows where it's going to be sending that data, and that's pretty much it on that setup. Okay, so once you have enabled that DS8000 object store on the 7700, you can go onto the cache partition page. And here is where you're going to resize that partition. If you are a tape or cloud TS7700 backend user, you'll know this page very well. But if you are a tapeless, then you might not have ever seen this page before. because it doesn't really apply. It never applied until now to a disk-only system. So for a disk-only system, you'll now have this concept of having this cache partition 0, which is where all of your tape logical volume resident data has gone through. It's just that since everything went to this partition 0 that already exists in your system regardless, you just never saw this page because there really wasn't anything that you could do with it. Now with your new object partition, which is showing cache partition 1 here, you'll be able to resize that partition. When you resize it, you are taking away from your cache partition 0. So in this particular case, if it's currently showing a 71 terabyte capacity on cache partition 0 and 120 terabytes on cache partition 1. If I reduce cache partition 1 to 100 terabytes, that 20 terabytes would go back to cache partition 0 and vice versa. If I increased it, it will be taking away from your cache partition 0. In here, we also show the object count, if this is an object partition, very similar to the volume count that we showed before. All right, next slide. Just some extra items that you should know about. Library request had been changed to include some additional items to support this feature. You may have been used to do, if you use library request commands, you may have been used to using one that's just called cache. And we've kind of overloaded cache, so we made a cache 2. And here, this will give you additional information about your cache partitions, and specifically this new column that you see that says TCO, which stands for tape, cloud, or object. Since you could be a tape attach or cloud attach, or be a DS8000 object store, this will tell you what that cache partition is about. So in this case, this is off of a disk-only system, because you can see here, none of the cache partitions say that they're tape or cloud. And cache partition 1 shows that it is an object store. So you see the little Y there. So that kind of just describes what kind of cache partition that is. Next slide. Library request settings 2 has some new knobs in it, and resd O for object. There's a low and high setting. If you are, again, a tape or cloud user, these settings will be fairly familiar to you. Basically, these are alert settings. You're going to be stating that when I reach this high or low setting, I want to be warned. So you set that value in gigabytes for your cache partition. So if we reach that level, you will get a host notification through the FICON channel, just like all the other library request alerts that tell you that you have reached that limit. And once you hit that high limit, then you should be kind of maybe worried or panicking at that point. But the low limit is just again to give you a heads up. You'll want to go and maybe resize your cache partition, or if you're running low on cache, you're going to want to do something about that. Next setting. And then this came out in release 4.2, this grid link library request, just kind of, it gives you like a point in time status of the activity that's happening on your grid links. And we've expanded it to the columns in the red are the additional items that we've added, where we can now see, well, how much workload do I have coming in and out of these clusters based on just copy data or potentially read-write data for logical volumes. And then now we've separated that data out for object send and received items. So you can see how much of that bandwidth that you're using on each one of these grid links is used by that. And the other item is, if not very common, but we do have a concept of grid-to-grid migration. So I'm just showing here that we also expanded that out for that feature. It has nothing to do with object store, but if you are involved in any grid-to-grid migration activity, this will show how much of that activity is based on that feature. All right, next. And management interface changes, just a pretty standard. This is just showing that you can now see how much of your cache is being utilized by objects versus logical volume data. And this is also on cluster summary, where you have the little cache tube. You can see how much of your object partitions are being utilized for that object data. Some changes in historical statistics page, and then grid link throughput pages are some areas that we've made some modifications to. Right. So what happens if a TS7700 needs to come offline for service, and you are forking to 2 clusters from a DS8000? DS8000 has a mechanism that will start tracking the transactions that have not made it to the other 7700 while that 7700 is offline. Once that 7700 comes back online, then DS8000 drives the resync of that data until it's completely back in sync between the 2 clusters. Next slide. Another consideration that you should have is regarding distance of the 2 clusters if you are forking. So you could have, you know, 1 cluster in the US, and you could have another cluster in the UK. And what does that mean if I am forking data through this synchronous write? And it is something that the 7700 team also has to deal with clusters in those same distances, you know, across seas or across the country. We have that same issue. And for those customers that do synchronous copies, they typically use IP extenders to do that. And this basically just kind of shows you how much of a benefit you will get with an IP extender in your network, under your network system. So this also applies to that data coming from a DS8000 to 7700s, you know, is how do I reduce or eliminate that latency, because, you know, that copy is not going to finish until the longest copy happens. So there are a couple of brocade solutions that are shown here that have these IP extenders that will help in that situation. And that concludes the 7700 side of things. So I am going to turn it over now to Robert, and he's going to talk to you about DSS full volume dump and restore that just came out this year.
And Robert, before can I interrupt you real quick? If
Yes.
anyone that's in the audience has a question or has something that they want to ask, please feel free to use the chat window. Lori will be being able to answer those questions as they come in. So you don't have to wait to the very end if you have a question. You can do that while the presentation keeps on going. So.
Yep, there are a couple questions about secure data transfer. So.
Good.
So I'll try and leave a little bit of time at the end as, you know, as other questions come up. But thanks, Eddie, and thanks, Lori. So when we've been talking about transparent cloud tiering, primarily it's been, you know, we've been talking about HSM migration, right? And that's archiving active data, or it's actually using HSM to migrate active data, right? So that's that DB2 image copy, flash copy use case, right? We flash copy our active data, and then we use HSM to migrate that out to the 7700 as an object store. What we delivered this year in September is the ability to dump entire zOS volumes using TCT, right? And so what we do is we've updated our DSS dump full and restore commands, and then we've provided a set of utility commands to list and delete the dumps that we've created out there. And we'll go through those as we go on here. So the full volume dump support, the primary use case here, right, is you have some production volumes, and they might be your sysres volumes, or they may be some other set of volumes. And you're going to flash copy those using DSS with flash copy and dump conditioning. And then you're going to use the DSS dump full command to dump those flash copy targets out to the TS7700 as an object store. So that's very simple. One use case, you may roll out sysres volumes to other sites. That's a good use for the full volume dump support. Or you might start looking at building this into your cyber resiliency strategy, right? You may keep some number of copies of your data online. And then you may only have 10 or 12 copies online, and you may want to keep more than that, and you can spin those copies to your object store. One way, yeah, that's fine. And so a dump isn't good if you can't restore it, right? And so we allow restore full support. The volumes can be restored directly back to production, right? Or they can be restored to a different volume on a different LPAR, right? And that would be more for your forensic analysis and your cyber resilience strategy. One thing to add, when you're creating these full volume dumps, most likely it's going to be a flash copy target, right? Now you can use DSS to create those flash copies. One key is that DSS requires the input volume to the dump command to be online. Now, if you do a flash copy, that's copying the entire volume, and that means it's also copying the volume label. So normally that flash copy target is offline. If you use DSS to do the flash copy, we have a dump conditioning command, right? And that allows us to condition the flash copy target volume to make it look like the original source, but it allows it to be online so we can dump it. Now, you may not be using DSS flash copy to create your flash copies, right? You may be using some other tool, and that other tool may create, the flash copies it creates may be offline. And so if you want to use DSS to dump those out to the object store, you need a way to bring them online, and you can use ICK DSF reformat to condition those volumes so that they can come back online and then dump them out to the cloud. So there's a couple different ways to get these volume dumps going. Next slide. In the initial TCT support, there were really a few inhibitors to using DSS natively. And along with the dump full and restore full support, we've delivered support to sort of remove those inhibitors, okay? So the first challenge was that the password or credentials used to authenticate with the DS8000's HMC were in our JCL, okay? And what that meant is that your JCL for the dump and restore jobs, they had to be in protected libraries, and really it may have been a showstopper for you. So what we've done is we've added a new keyword. It's called CDA creds, and that allows us to store the credentials encrypted in the Unix file system, and then we can use them at runtime to authenticate with the cloud. And what that means is there's no more password in the JCL. In the slides we've uploaded, there are some slides in the backup that would show you how to go about configuring what we call CDA or Cloud Data Access, securing those credentials so that you can use the CDA creds keyword. The second challenge was that the dumps we create using DSS are not cataloged. You can't go out to ISPF and say, tell me the dumps I've created for this volume, right? There's no inventory. So what we've done is we've added a new cloud utils list command, and this will allow you to list the dumps you've created for a particular, in a particular cloud, in a particular container. And so we could envision using this cloud utils list command along with job logs that created the dumps to act as an inventory when it comes to recovery. And finally, there's no automatic management or expiration of these dumps created in the cloud. So if you create a dump on virtual tape, there's all sorts of retention policies, expiration policies, management software around that to help expire and manage that data that we write to virtual tape. That doesn't exist yet for Cloud Object, right? So what we've done is we've added a cloud utils delete command to allow you to delete these dumps and expire them off as you need to. Next slide. So really quickly, before we put this all together into a real use case, the Cloud Utils list command, this allows you to list all the dumps in a particular container or a set of dumps in a container. And we have facility classes that control access to this command, just like any other commands we have in DSS. Similarly, the Cloud Utils delete command, you can delete a dump, you can delete a set of dumps, or you can delete an entire container, okay? We have facility classes to control access, and by default, the delete Cloud Utils delete command will not delete a container that isn't empty. So we have a force command that says delete a container, even though it's not empty. And there's some additional facility classes to control access to that keyword as well. So let's put this all together. Let's take our new CDA cred support, our Cloud Utils list and delete support, and let's simulate a use case here where we want to create nightly dumps of a volume or a set of volumes, and we want to keep 1 week's worth of those dumps. So we're going to have a container. It's going to be named DSS dumps, and we're going to keep a week's worth of backups of a volume named vol001. And what you're going to see is we're going to use the ISPF file tailoring service and some recs to generate the JCL that we'll use to run nightly. So the reason we need to use recs and we need to generate JCL is because we need to do our own expiration. So if we want to keep 7 copies, when we create a dump, we need to delete 1 from the past. And that means we need to sort of generate the name of the thing we need to delete. And so that's why we need to use recs. So the first step is we'll come up with some JCL skeletons. It's going to do the copy full. It's going to do a dump full, followed by a Cloud Utils delete command. Okay, so the copy full will copy our prod 001 to flash copy FLC target. And we'll do the standard flash copy, no copy, preserve mirror, and dump conditioning. And then we'll dump that off to the cloud in our DSS container and with a particular object prefix. Okay, so it's up to you to choose an object prefix naming convention. And you want to choose a prefix name that allows you to support multiple dumps of the same volume in a container and multiple versions. So multiple volumes and multiple versions of the same volume in the same container. So what we've done here is we've used a symbolics for a job name followed by the volume followed by a date. Okay. There's probably other ways. You can maybe use sequencing, but we'll use date for our example. Next slide. So I've included some recs that you are happy to use and augment and update. And there's some contributors up top. So this is an original content. But what we do is we have these symbols in our skeleton, right? And we write some recs to substitute actual values for those symbols. And really the key one is the expire date, right? So after we create a good dump today, we need to expire the one from 7 days ago. And so we have to do some manipulation with dates and come up with an expire date that we can then fill into our JCL. So let's say you want to go and run your backup jobs. You're going to run this recs to generate the JCL. It's going to fill out all those symbols. And assuming we took a good dump, it'll go and delete the dump from 7 days ago. And suppose you need to recover one of those backups, you can use the Cloud Utils list command, right? So we'll list that container with a particular object prefix for that vol001. We see that we have 7 backup copies from those days. When we can go and substitute the object prefix, right, on the restore JCL. and run that job to bring that volume back to DASD. So the dump and restore full support, it is available on zOS 2.3 and 2.4 with PTFs for OA57526. That support includes the CDA creds support as well as the cloud utils. It is supported on both the 8880 and 8900F with microcode upgrades. 8880 requires 8.5 Service Pack 6, and the 8900F requires microcode for 9.1. And we have some publications here for your reference that you can go and take a look at. And with that, thank you. There's a couple questions. Lori, were you able to answer the secure data transfer ones, or should we talk about those?
I'll maybe talk about, so the question didn't state whether we were talking about targeting a 7700 or traditional. I just answered the one targeting a 7700 because I know it's different. So I don't know, Eddie, if you want to elaborate on both.
So we do. So in terms of encryption, we do have two different encryption technologies in the DS8000. So when we target a S3 compatible cloud, it uses a different methodology in order to do that encryption. It does, that methodology requires an external key server, because what we do is we encrypt the data such that when it goes to the cloud, especially like a public cloud or something that's outside of your data center, you want that data that lands in the cloud to be encrypted. So what we do is we encrypt the data in the DS8000, and then as it lands in the public cloud, it will also remain encrypted, and it's decrypted when it's brought back into the DS8000. That technology or that methodology requires a key server or an external key server, such as SKLM, Gemalto SafeNet, those KMIP external key servers. Secure data transfer is a little different. Secure data transfer is just encryption of data in flight. And it's just basically the data that's encrypted is decrypted when it lands in the TS7700. So we don't do any sort of requirement for an external key manager. We actually do internal key distribution between the DS8000 and the TS7700. So just try to clarify the differences between the encryption to the public cloud and private clouds and TS7700. Hope that answered the question.
Okay. What I'll do now is anybody can unmute themselves if there are any further questions. We don't have a great deal of time left. We have to hand the virtual room back shortly, but there's probably time for a couple of quick questions if anybody has any.
Nigel, I'm trying to think how to say my question, but I can't think it. I was involved with that pervasive encryption talk that was earlier today. So what the guys are basically saying is that when the data goes out to the cloud, if it's not been encrypted, it then gets encrypted so that nobody can get at the data if it's a public cloud, as you've stated. But if the data is already encrypted using the hardware feature of a Z15, then it's not necessary to then encrypt it when it goes out to the cloud. So SMS understands that it's already been encrypted, basically, yeah?
That's correct.
Right, so you don't get like an encryption of an encryption, basically, is what I'm asking.
Exactly. So DFSMS understands data sets that have gone through data set level encryption. And what it'll do is it'll tell us not to encrypt it. So basically the data is already encrypted on disk based on data set level encryption. So we'll just send it as is to the cloud, and it'll continue to be encrypted. The decryption is done when it gets read all the way back into the host.
Right. Okay. Thanks very much.
Welcome.
Okay. Are there any further questions? Okay, if not, then by some miracle brought about by the professionalism of our speakers, we've actually finished exactly on time. So I'd like to thank Robert, Eddie, and Laurie for getting up at some entirely unreasonable hour to give us a very good and very complete presentation on what I find to be a really interesting topic. I mean, I know that outboard data movement has been something that's been talked about for many years. There've also been rumblings about the inefficiencies of HSM tape handling, and we have both coming along at the same time. I'd also like to thank them for updating the slides since this presentation was given a share. So I noticed that that these are absolutely up to date with the latest information. So thank you very much, all of you. Unless there is a final chance for any last questions, I'd like to thank you for attending. Please do the feedback. I've pasted the link in the chat. And thank you again to our speakers. Unless there's anything else, I'll close the session.
Thank
Thank you,
you.
everyone.
Thank you.
Thank you very much.